Hi, welcome back guys. We're looking at 3-3 proving lines parallel today. If you think there's going to be some proofs involved, you are correct. Okay. What's nice about 3-3 is pretty much all the theorems we learned in 3-2 are exactly the same, just in reverse. We use the converse. Remember, converse is the reverse. Last section we said that corresponding angles on parallel lines are congruent. This time we're going to say if corresponding angles are congruent, then the lines are parallel. Okay. Actually, it says if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So it's the opposite of what we did yesterday or the other day. Okay. So pretty much use this for is if you see these two lines, you know this is 45 degrees. You know this is 45 degrees. You say L and M are parallel. But now if I go and I say this one's 55 degrees, then I say L and M are not parallel. Okay? And you may be saying, why do I need to know that? Well, let's say you're building something, you're making train tracks, and you want them to be parallel. You check and make sure that each track is meeting up at the same angle to each rail. And then if they're parallel, your train won't be derailed. Okay, let's take a look at this one. So we have four lines all crisscrossing. We have L and M next to each other. We don't know if they're parallel. And A and B next to each other. We don't know if they're parallel. So now we know 1 and 2 are congruent. So this guy and this guy. So we're asking which two lines can we tell are parallel? Well, here's a big piece of advice for you. We know 1 and 2 are on line M, A, and B. We know M's not parallel to A and B because it crosses them. A and B are the only two other lines involved, so we know they're going to be the ones that are parallel. But if we're actually using our theorem, we can say upper right. I think A is going to be parallel to B by converse of corresponding angle theorem or postulate. Okay. So, because angle 1 and 2 are corresponding angles on A and B crossed by transversal M, so I can say those are parallel because those two angles are congruent. Oh boy. I hope I didn't make you guys write all these. Okay. Pause for a second, think about. We have our alternative interior angle, same side interior angle, and alternate exterior angle. All the same exact theorems you guys learned last chapter, but in reverse. Okay? So I want to give you guys a second, read that over, think about it. While you do, I got a joke for you guys. What do you call ham that you really want? Porcupine. Huh? Okay, I tried. Okay. Let's look at this diagram to the right because it tells us to. Theorem 3-4, converse of alternate interior angle theorem says that alternate interior angles are congruent, then lines are parallel. So we're looking at 4. Now, which one's alternate interior to 4? Well, we have to jump over that line, stay on the inside, and we get angle 8. Okay. Now, 3 is supplementary to something. So we look at 3. Well, this says same side interior angles. So that means we do not jump over a line, but we stay on the inside. Okay? So we stay inside, we don't jump over a line. Oh, it must be 8. No, I'm not going to. I'll put a dash line because those are not congruent. They add up to equal 180. And lastly, we'll use green. 3-6 is the converse of alternate exterior angles. So angle 1 We have to jump over because it's alternate, stay on the outside, and 7. Okay. Anything too scary? Better put that question mark. Come in with your questions. More than happy to answer them. Okay, similar question before. We know 6 and 7 are congruent. What two lines are parallel? Well, B crosses through L and M, so we know B is not going to be involved in this. It looks like I have 6, and then I stay on the same side and go down here. That looks like corresponding angles. So I would say L is parallel to M by converse of corresponding angles theorem. Okay. 2 more slides. We're 2/3 way through. Okay, this is my introduction to flow proofs. We're going to have 3 types of proofs at our disposal. You're going to have proof boxes, flow proofs, paragraph proofs. Flow proofs are actually one of my favorites because it's kind of the way your mind thinks. You start at one thing, you go on to the next, to the next, to the next, and all you do is have to add your justifications on. Okay, so go ahead and read this over. Given that angle 1 is congruent to angle 7, prove that angle 3 is congruent to angle 5 using the picture to the right. Okay. Well, what's our given? That's right, angle 1 congruent to angle 7. Okay. How do we know, let's go down here, how do we know that angle 1 is congruent to 3? Make that bow tie, they're vertical. Vertical angles are congruent. Now if 1's congruent to 7 and 1's congruent to 3, how can I jump to 3 is congruent to 7? Remember, 3 is connected to 1, 1's connected to 7, so 3 is connected to 7 by your transitive property. Okay. Now we go down here. Angle 7 and 5, or 7 and what are vertical? If you said 5, you are correct. Now again, 3 is connected to 7, 7's connected to 5, so that means 3 is connected to 5 in a roundabout way by our good old transitive property. Okay? So pause, soak that all in, take a break. Got it? So we have 2 transitive properties, 2 vertical angles, and a given. Okay. What value W would make C and D parallel? Well, these are corresponding angles, so those have to be congruent for those 2 lines to be parallel. So what do you do if they're congruent? You set the values equal to each other. 55 equals 3W minus 2. Then we use algebra. Add 2. Add 2. 57 equals 3W. Right? And then, I'm going to grab my calculator. You know, 57 divided by 3 equals 19. And that's all there is to it, because when we plug in 19 for W, we end up getting 55 and 55 for our corresponding angles. Hence, those 2 lines are parallel. Well, that's it for the day. See you guys tomorrow.